So I think you can see my screen okay. I'm absolutely delighted to be here and to speak at the launch of this institute. I'd like to say a few words on data-driven design and uncertainty. And first, perhaps to let you know a bit about who I am and who the team are at Imperial. So I'm a professor of systems integration at Imperial College London, but just to tell you a bit about our team, to tell you about our motivations around uncertainty and digital delivery, and then to talk about the work that we're doing on data-driven design under uncertainty, and then to conclude. And I lead a centre at Imperial College London, co-director of the Centre for Systems Engineering and Innovation. And we're celebrating 10 years of the centre, and we've put together a 2030 vision. And we've got a core team of researchers. We engage with a range of industry partners and with policy stakeholders. And so when I'm talking today, I'm going to give you a bit of an overview of the work that we're doing on data-driven design under uncertainty. But I'd really like to emphasize that our approach to that work is to look across disciplines, to think about how engineering disciplines come together, and to work with industry partners to look at how we can use these techniques in practice in construction. And so we've been engaged in a range of activities in real life and over the last year online. And I've been involved in policy work in construction in the UK, most recently working on the construction playbook, but also sitting on the senior advisory group for Construction Leadership Council. And so engaging with industry and policy around how they uptake digital technologies and how they think about data-driven approaches and artificial intelligence. And what I'm really going to talk about today is the work that we've been doing with the Alan Turing Institute, and that's the National Institute for Data Science and Artificial Intelligence in the UK, as part of their data-centric engineering programme. And so this programme is funded by Lloyd's Register Foundation, and it has 3 grand challenges. I lead one of those grand challenges. And then it has a significant body of fundamental work on the mathematics and computer science behind data-centric engineering. So the 3 challenges, the 3 grand challenges, are around resilient and robust infrastructure. They're around monitoring complex engineering systems, and they're around data-driven engineering design under uncertainty. And these grand challenges are about taking the fundamental work of the Turing Institute and looking at how that might connect with grand challenges in society and in industry. And so the focus of my work has been around data-driven engineering design under uncertainty. And so connecting with the work that I've been doing in construction and infrastructure, and trying to look at how we can use these techniques that are being developed out of the Turing Institute in practice. And so just to talk a bit about the motivation, and I mean, this is my personal motivation. My personal motivation is this sort of question about how we can have good people, good engineers with good engineering skills that can fail to deliver successful projects in the built environment. So in terms of buildings and infrastructure, and that's really a question that motivates a lot of my interest in how we use digital technologies, how we use data-driven approaches, how we use AI to improve project delivery. And we had a major failure in the UK on a retrofit project. So this was a Grenfell Tower disaster. So it's a high-rise building that went on fire. What I want to touch on here is some of the thinking that's gone on in the industry post-Grenfell. So there's been a report by Judith Hackett, who's a chemical engineer, looking in at our industry, our building and infrastructure industry, and saying that you need to operate more as a safety critical industry, and how can you think about yourselves as a safety critical industry. And so she did an independent review of the building regulations and fire safety in the UK. And I sat on her committee that was holding the industry to account before I joined Construction Leadership Council. And she was really clear about the systems failure, the lack of clarity on roles and responsibilities, the lack of a golden thread of information, and also very frustratingly, too many people saying that they knew something like this would happen after the event. And so I think there are some real practical challenges in terms of improving the way that we operate in the industry that are a context for how we then think about how we use digital technologies and data-driven approaches and artificial intelligence in the sector. And actually the uncertainties in this sector are only getting greater. And I think Elisa touched on this in her presentation before the break around the kind of challenges that we're facing with climate change and so on. So I would argue that infrastructure complexity is growing, and in some cases it's outpacing engineers' ability to address it. And actually there are new kinds of cyber physical complexity that make that even more complicated or even more complex. And on the left-hand side of this slide is a picture of Crossrail. And we did a lot of work with Crossrail. It's a major infrastructure project in London. And they've had really significant challenges of systems integration in terms of getting the systems to work together, so getting different bits of engineering to work together ahead of opening. And they're not entirely in the civil engineering. They're actually more about the control systems, more about the services that are in running through train tunnels. And so I'm very interested in how we get different engineers to work together on some of these problems and how we can use these techniques to look at interfaces in these kinds of big projects. We've been thinking a bit about uncertainty recently, and this is really kind of early doors thinking about how we conceptualize uncertainty in the program of work. And there are kind of three types of uncertainty that are talked about in the literature. So there's aleatory or statistical uncertainty. That's about the random stochastic nature of engineering systems that are non-deterministic. There's epistemic uncertainty about knowledge, where we've got missing or incomplete information. I think personally, the thing that I think is more interesting is this sort of radical uncertainty, which is the uncertainty that we today think is unquantifiable. And parts of it may always be unquantifiable, and it's variously discussed as radical, Knightian, genuine, or in the case of long-term infrastructure and long-term adaptation of infrastructure in relation to climate change, then people are talking about deep uncertainty. And so we've been thinking about data-driven design under uncertainty in the context of these large infrastructure projects on which I've been studying over the last 20 years. And so I've been working on how these projects, the delivery of these projects, have been changing as a result of digital technologies and the uptake of digital technologies. And so over the last 20 years, we've done a series of studies at Heathrow Terminal 5, at the London 2012 Olympics, at Crossrail, at Tideway. Increasingly now I'm working with High Speed 2, looking at how they are increasingly digitally integrated in the way that they deliver, and how digital information being shareable, accessible remotely, searchable, updatable, is changing project deliverables. So these projects are now delivering a digital set of information as well as a physical asset. It's changing the supply base interactions, and so the visibility of the supply chain becomes Interesting in the project can monitor the supply chain performance better. I think this piece is absolutely crucial for dealing with net zero in our industry. So being able to have information about the supply of materials in a more comprehensive way, and it's also changing the relationship with owners and operators and end users really quite fundamentally. And I think we're seeing a lot more integration across use and operation and delivery. And so we've been interested in working with major projects and with the companies that work on major projects to understand how practices are changing as a result of these pervasive digital technologies. And there's a range of our thinking on the slide around the sharing across the life cycle, to and from end users, the cloud-based systems, the questions about security that this raises, the linked data, the access management, and how patterns can increasingly be analysed to inform decision making. And that's really where we're focused on the work that we're doing on data-driven design, and then the input from sensors and users being fed directly into integrated software and starting to become part of the material that can be used in design processes. So just to go through quickly, we did work on Heathrow Terminal 5, particularly looking at how they went from the digital model to the physical infrastructure. We did work on the Olympics around data handover into operations and the challenges at this scale of integrating design data and making that useful through into operations. We did work with Crossrail on configuration management and managing change, and we got Airbus and CERN and Crossrail together to look at some of the challenges of managing design change in large data sets. And more recently, we've been doing work with Tideway on the digital twin. And so just to deep dive into one of those studies that we've completed recently, I'd just like to highlight Dr. Ranjit Soman's work on linked data-based constraint modelling and checking for AI-assisted look-ahead planning, and he's looking at the kind of 6-week look ahead stage. So when you're on the construction site and you're looking to move from the long-term plan to the work on site at that six-week look ahead planning stage, you tend to be integrating data from across a whole range of different data sets. And so looking to use linked data-based approaches to improve that process, and also then use reinforcement learning to improve the quality of planning at that stage. And so we've had this broad interest, and we've got a number of detailed projects going on around this question of delivering the digital delivery of major infrastructure projects. And I want to talk a bit about the programme of work that we have on data-driven design under uncertainty with the Turing Institute. And again, I'm going to talk at quite a high level, quite a high overview. And I'd be happy to answer more detailed questions either in the chat afterwards or as a follow-up. But just to give you a bit of an overview of the work that we've been doing through the Turing Institute. And to start with this kind of question of design, and I think Elisa has given us lots of flavours of how AI can be used in generative design and in architectural design. We've really been thinking about design and delivery in terms of how you bring different disciplines together across a major programme of work. And so we've been thinking about it in terms of the systems engineering kind of V diagram, where you're working down partitioning the system and then you're integrating it again. And what we've been finding is that we have lots of techniques for engineering problem solving, and we have techniques for using operational data ex ante and ex post, and these are very useful techniques, and we're working with them. But we're also interested in this question of how do you apply some of these techniques in that more uncertain phase of design. So information uncertainty increases through the design process, but the ability to make changes decreases. And so Peter Childs in the Dyson School of Design Engineering says that engineering problem solving is the activity associated with tackling defined constraints, whereas design, viewed as the transformation of an existing state into a preferred state, also involves negotiation, exploration, discovery, and the definition of constraints. And so we've really been thinking and talking about design in that way. So in this program of work, our themes are around infrastructure, around complex systems, around people-centric design. And we've had a focus on predicting systems interactions and potential failures, model integration, problem structuring and scenario generation, bringing knowledge from operations into project delivery, managing design changes, sensitivity analyses. And I'm going to talk through quickly the four core projects as part of this theme around data-driven design assurance, data-driven design of civic infrastructure, the digital twin and design for retrofit. We've been fortunate to have a range of associated research and Dr. Ranjit Soman and Dr. Karim Farhali are working on the AEC production control room work that sits alongside this programme. We've also had visiting professors come and visit us at the Turing Institute, including Birchin, who I know has spoken as part of this programme. And we've had opportunities for people to spend time at Turing as part of this work. So we've been looking to do work on design assurance, and I think this project perhaps highlights one of the challenges of getting quality data. So we were in discussion with one of the major infrastructure projects in London about getting their design assurance data and then using that and using text mining and natural language processing techniques to provide insight into the design assurance practices to then inform the next project. Now, there are various challenges in terms of getting the quality of data that we would have liked, but not least contractual issues in terms of getting that. And so we've done some work on other aspects of design in this program, including some work on adjacency constraints in floor plans. The second piece of work is around data-driven design of civic infrastructure. And here we're looking at that early stage conceptual design and the optioneering, if you like, of different kinds of approaches. So understanding, using stochastic programming type techniques to understand the different options for transportation systems. The third piece of work is around design change in digital twins. And here we've been developing new methods to visualize the impact of design changes. We've done some work identifying changes using SCAN versus BIM. This work actually, we've collaborated with Stefan Nutenegger, who was in the computing department in Imperial and has just joined TUM, and so creates a bridge to connect with people in TUM. We've taken that idea of scanning and understanding what's in the site and comparing that with your BIM model to calculate change propagation using a design structure matrix, and then to look at collaborative decision making and better design. And so we've been doing work. Long Chen, who's now gone and become a lecturer at Loughborough University, has been doing work on design change and semantic enrichment to look at change propagation in the BIM model. Colleagues have then been looking at how you visualize this kind of information on the construction site, inspired by the kind of NASA mission control room to think about the AEC production control room and how you look at data and how you're collaboratively able to interact with data on the construction site. So the fourth piece of work then is on retrofit design in the built environment. And I think this is an important and perhaps increasingly important area where we're increasingly not building on greenfield sites, where we're having to think about how we maintain and upgrade and interact with our existing infrastructure, and particularly to make that more energy less energy consuming. And so this is work thinking about how you engage with that building energy modelling, and how you address uncertainty in that, and how you then make that available to end users. And in this work, when you're looking at domestic retrofit, then you're talking about end users being general public living in the houses, trying to make decisions about how to retrofit their houses, or you're talking about landlords that own an estate of properties. And so just to make a few concluding remarks and then to open for questions and discussion. I mean, we've been thinking quite hard about engineering design and how that multidisciplinary engineering design and coordination across the putting together of large systems is different in some ways from engineering problem solving. And so we see design as an important area for data-centric work. We're interested in uncertainty in data-driven design, and we're both interested in that in terms of modelling and using AI, and we're thinking at the moment quite hard about how can we articulate the decisions about different kinds of modelling that are available for different classes of problems, because this is something that our colleagues working on these major projects really struggle with, is what kind of approaches would be relevant to different classes of problems that they face. So we've been thinking quite hard about that, and we've also been thinking about how you then help people to question assumptions in those models. And I think for me, I've always been very interested in these large visual displays of information that allow people to come together and have a conversation around the digital data. And I think that's particularly useful in this design process. So we've been thinking about the AEC production control room in that way. There's a couple of examples on this slide. And I think there is a real opportunity for new techniques and for new work in this area. Just to flag quickly before I finish, we're putting something together for the Data-Centric Engineering Journal that's run by Mark Girolami. And I think that's a great outlet for the kind of work that we've been discussing over the last couple of days. And so just to flag that journal that's associated with the programme. And thank you. Open for questions.